All right, let's look at the problems that were the most wrong in last night's homework. So this was a whole series based on this chart. You had to read the chart and see how many outcomes there were of spinning the number 1, the number 2, 3, and so on. So what I did at the top of each bar is I actually put the number of outcomes for that number spun. So this question says the relative frequency of spinning a 6 is what? Well, here's a 6. There were 7 outcomes out of a total of 50 spins, and I got 50 because I think your direction said out of 50, or they were expecting you to add it up. But if you add up all of these numbers, it does equal 50. So the relative frequency of spinning a 6 is 7 out of 50. So it would be 7 out of 50 would be the answer for this one. All right, for this problem now, the question is, what's the relative frequency of spinning an even number? So it's using the same graph, and the even numbers in the graph would be 2, 4, and 6. So we have to add up the outcomes for the 2, the 4, and the 6. So if we add 6 plus 11 and 7, we're going to get 13. We're going to get 24. Is that right? That's 7, that's 14, yep, 24. So then the relative frequency of spinning an even number would be 24 out of the 50 total. And yep, you could simplify that, divide top and bottom by 2, and you'd get 17 out of 25. Okay, this problem is using the same graph again. And it says you want the experimental probability of spinning a number less than 3. Well, a number less than 3 would be 1 or 2. And the numbers of spins that happened that were less than 3 were 8 plus 6. So we have 8 plus 6 is 14. So then if we take the number of outcomes that we wanted, which was 14 out of total of 50 spins, we get 14 over 70, and if we divide top and bottom by 2, we would get 7 over 25. All right, for this problem, again using the same graph, it says the experimental probability of not spinning a 1 means anything other than a 1, which would mean you're looking at the data for 2, 3, 4, 5, and 6. So if you add up 6, 9, 11, 9, and 7, you get 42. So this would be the top number, the number of favorable outcomes over 50, which is still the total outcomes. And if you simplify that, you'll get 21 over 25. Now there's an alternate method that you could use. You could take the probability of spinning a 1 and subtract that from 100. So if I have the probability of spinning a 1, that's going to be 8 outcomes. So if, actually that's not right, it would be 50 minus the probability of spinning 1, which would be 50 minus 8 would give us 42. So that's another way that you could get to this number. All right, still using the same graph. You're looking for the experimental probability of spinning or 1 or 3, which means you want how many times did 1 get spun and how many times did 3 get spun, and 8 plus 9 is, let me get my pen, 8 plus 9 is 17, and we would have 17 over 50. All right, I know this problem's a little bit difficult to see, but I'll read it. You check 20 cartons of eggs. 3 of the cartons have at least 1 cracked egg. You want the experimental probability that a carton of eggs has at least 1 cracked egg. So you're looking for the probability that the carton has 1 cracked egg. So if I go back to the problem, there were 3 cartons that had at least 1 cracked egg. and the total number of cartons that were checked was 20. So that would be the bottom. So my experimental probability would be 3 out of 20. All right, in this problem, it says there are 105 lettered tiles in a board game. You choose the tiles shown. How many of the 105 tiles would you expect to be vowels? Well, this is a sample of the tiles that you're pulling from the game. There are 7 tiles in the sample. And out of the sample, the number that are vowels is 1, 2, 3. So then my experimental probability would be the number of vowels over the sample, or over the whole, would be 3 out of 7. This means I could actually set up a proportion to estimate out of 105 tiles how many would I expect there to be vowels. Well, I know 7 times, I believe it's 15. 15 times 7, 5, that's 105, yep. So 3 times 15 would be 45. So we would expect 45 vowels out of the sample of 105. All right, use the spinner to find the theoretical, we're looking for theoretical probability of spinning a multiple of 2. So now theoretical means out of my choices on this spinner, how many are multiples of 2? Well, the multiples of 2 would be 2 itself, 4, and 6. So that would be 3 favorable outcomes out of 6 total, which would be 1/2. Okay, so this one looks confusing, but it's not. It says the bar graph shows the spinner was spun 200 times. So we had it spun 200 times. So this bar graph shows me the outcome of spinning the spinner 200 times. It says compare the theoretical and the experimental probabilities of spinning a number greater than 4. So I want a number greater than 4. So probability that it's greater than 4. So theoretical means just based on this spinner, how many outcomes are there that would be greater than 4? Well, the outcomes that would be greater than 4 would just be if you spun a 5. So out of the 5 possible outcomes, 1, 2, 3, 4, 5, out of the 5 possible outcomes, you only have one chance of spinning greater than a 4. So the theoretical probability would be 1/5. Now it's asking you for the experimental probability, which means I'm looking for, again, the probability that I'm going to spin a 5. So for the experimental, I'm looking again for the probability of spinning greater than 4. So I'm looking for this piece of data. So out of a total of 200 spins, I get 40 that are a 5. And we can simplify that by dividing top and bottom by 40, so I get 1/5 as well. Now, the experimental probability is what of the theoretical? Well, in this case, it's actually the same. So we would say, and I know this was a drop-down menu, but I would say they would have to be either equal or choose the same.